Yes, we are making the classic settings we always do. We activate cavity and bolt. I change the measurement unit of our scene to centimeters. We enter edit mode by selecting our cube. Here we can delete the top surface of our cube. The lower surface may remain. I activate edge lens to see our measurements. We adjust the size of our building. We assign a UV map to our object by calling it cube projection. We open the UV editor by opening a window from the side. We load the cladding of our building here. Here we scale the UV map of our cube to the size of our coating. We also adjust its width as we want. We scale the edges of our building to the edges of our texture. To make our model look more realistic, we divide the window parts with loop cuts. When the division process is completed, we select the surfaces that will be windows and extrude an average of 4 cm inward. You can see that this way we get a more realistic image. You can name our materials if you wish. This way we avoid confusion. By copying the main material, we transfer the location to the material we created. We assign the selected glass surfaces to the second material. So we throw it. We open a new window and open the shader editor here. We reduce the roughness value of the window material so that we can get a smoother reflection. Now we can start building the upper floors of our building. Third, we add a plane by moving our cursor to the center of our building. By activating our snap feature, we enlarge our plane in edit mode by scaling it according to the dimensions of the lower floor of our building. The upper floors are a little larger. We are also making the upper floor a little larger. We make our floor height 300 centimeters. While editing the video, I realized that I made the bottom part as 200 centimeters. You can also make the lower floor as 300 centimeters. Just like we did downstairs, we add material to our upstairs object and give it a name. In order to use the shortcut keys in the shader editor, we need to activate the Node Wrangle add-on. We go to the Edit Preferences section and search for Node Wrangle among the add-ons and activate it. The process is complete. While Principle is selected, we automatically add Image Texture with Ctrl-T. By clicking the Open button of the image texture, we select the texture in which we will create our building. We select our photo from UV Editor. In the UV Editor, we select the UV map and scale it until we get it to the dimensions we want. We edit the UV maps in the UV Editor by selecting the facing surfaces of our layer. We determine the window gaps with loop cut. We leave one window and select other window parts and extrude inwards. We wipe the glass parts where we made the extract. We leave one window behind. We select our only remaining window and extrude 5 centimeters inside. While the window section is selected, we press the Y key and turn it into a separate surface. We determine the wood and glass parts by cutting the window part with loop layers, just like we did on the bottom floor. We separate the window model from our floor model from the separate menu. We extrude the joinery part of our window 10 centimeters outside. In order to eliminate UV distortions, we select the adjacent surfaces and turn on UV by clicking Cube Projection. By moving them to the appropriate position, like wood, we make our window model look more neat. We place our window model into the window spaces one by one. Yes, in general, we completed our first floor this way. I forgot to mention it at first. After making the first window model, we assign separate materials to the glass parts and reduce the roughness value. We had already done this downstairs. We determined the center of the floor we built as a place from the lower points. Now we duplicate the layer we made on top of each other with the array modifier. Yes, we multiplied our floor this way. As a detail, we can add protrusions to the edges of our building, such as floor molding. Now you can adjust the number of floors according to your own taste. After deciding on the floor height, we approve the array modifier. By editing the last floor in edit mode, we cover it and create the roof part. If you want, you can protrude a little like this. Yes, you can now build as many buildings as you want according to your own taste with this method I showed you. To make our building look a little dirtier, we mix the black and white texture of our building with mix color. We make the mixing format overlay. You can also try different types of mixing. Now we add color ramp to the mix color output to create a roughness map for our building. We connect the color ramp output to the roughness section. For a more realistic look, we add bump by printing from color ramp. We also connect bump to the normal channel in Principle. In the final, we obtain such a building material. Yes, I built a few buildings quickly so as not to bore you any further. Now we are doing something like this here. Since our number of buildings is low, we will add more than one building to our scene. If we assign random color tones to these buildings, our buildings will look slightly different. We add mix color to the material that forms the main textures of our buildings. We're also adding a color ramp. We choose the color transition hardness as constants. You can add as many color ranges as you want by clicking the plus button. We adjust the color distribution frequency. We choose the colors one by one and bring them to the tones we want. I generally prefer to choose tone through textures. You can choose color tones using the droplet tool via texture, either yourself or like me. We connect the color ramp output to the B part of mix color. As a final node, we add object info to the input section. We attribute this to the factor part of color ramp. Now, when we copy our buildings, it will randomly discard the colors we determined. If you bring the factor section towards 1 in the mix color section, you will see that the colors we adjusted will appear more dominant. This is the final shape of our material scheme. We are gathering our buildings under a single collection so that we can choose more of them in the future. Now we can move on to designing our scene. We move our buildings aside a little. We close other windows to work on the wide screen. By adding a plane, we make the path of our street on it. After we build the roads, we build the places where the buildings will come. We select all of our stage objects and delete the overlapping vertexes by selecting by distance from the merge menu. We map out the future locations of the buildings with Extrude. Now, we return to object mode and place our buildings one by one in our scene. Here, we create a city image by placing the building we want wherever we want. On the other hand, we place our camera in our scene and adjust its angles. We set the height of our camera from the ground to 170 centimeters. We make the first 80 degrees of the camera 90 degrees so that it looks perpendicular to the scene. In order to look a little higher without changing the angle, we increase the shift Y value slightly in the camera settings section. We extend our path a little further so that it looks like a longer path. Yes, we have completed the construction of the city in a small way. Now let's make the materials for our roads and sidewalks. We assign UV map to our path by calling it cube projection. We make texture connections. We make the texture size suitable for the road by increasing the UV scale values according to our scene. We mix it with soil PBR texture to make our path a little dirty. We mix soil and asphalt material with color ramp. To make it more realistic, we connect noise texture to the color ramp factor input. We make our settings according to our scene. Now let's make a border stone to add a little more realism. We can simply make our border stone from the cube. After making the main model, we reveal our model by defining its lines with the bevel. Finally, we adjust the size of our model. We assign a UV map to our border stone by calling it cube projection. Then we assign the material. I am using concrete PBR map here. Since I want the stone objects that we will reproduce in the following sections to be assigned random texture positions when separated from the separate menu, we connect the random section by adding object info to the location section. Since I want some pollution on it, we mix it with a black and white coating and mix color. We also overlay the mixing format. Now we add our border stones to the edges of the pavements. Now we are adjusting the texture of our pavements. Again, we assign a UV map by calling cube projection. We make principal shader connections. From the UV scale section, we perform the scale process until it reaches the appropriate dimensions for our scene. Now we go to the page to download the Ivory Generator Geometry Note diagram. With this geometry note system, we can add vines to the objects in our scene. We are unloading junk cars to add our scene. I added the links to all of them in the description section. You can download them from there. If you look at our friends page, there are many beautiful models. You can download whatever you want, paid or free. I found a garbage model to put in different parts of our street. You can download this too. When you download these models, you download them as .glb. You can open GLB models in Blender without any problems. After downloading the models, we import them into Blender one by one. I cannot use this model because it is heavy on my system. If you can open it, you can use it. We move on to the next model. After importing the model, I pull it out of our scene. Here I turn all the pieces into one piece. By entering the edit mode, we delete the overlapping vertexes, making our model a little lighter. We switch to the camera angle and place our object in a suitable position according to the angle of our camera. Again, we download a different tool and import it into our scene. We place it in a suitable place for our stage. Now we import the garbage model into our scene. By entering the edit mode, we delete the overlapping vertexes so that the number of vertexes of our model decreases. We bring it to a suitable position on our stage and place it. Now we will make wooden piles to add our scene. Now we are opening a new Blender from scratch. We will create a wooden board using the cube object in our scene. We enter the edit mode and scale our object until it turns into wood form. We divide our model by adding vertical loop layers. We try to give the appearance of uneven wood by extruding or moving the edge points. We also make horizontal loop cuts to make different board models. We create uneven surfaces by slightly moving the vertices we assign to the edges left and right. In this way, we can make as many wooden board models as we want. After completing these operations, we make a model in the style of a pool. With this pool model, we will ensure that our wood is stacked realistically. We perform insertion by adding a plane. Then we give it thickness by extruding. We select the surfaces we insert and extrude them, and now our pool model appears before us. Now we bring our boards into our pool. By entering edit mode, we assign UV maps to our objects by calling them cube projection. We open the shader editor window and assign materials from there. And we choose our wooden PBR maps. We adjust the scale and rotation values according to ourselves. Since we want our object to be slightly aged, we mix our main color texture with a black and white coating. We also adjust the mixing format. From the mapping section, we connect the random channel of object info to the location section so that we can get a random distribution. We can add bevel modifier to the objects so that we can get a smooth transition on the edges in par style. Now we set the origin points of our objects. We can do it from the object menu. By saying origin to geometry, we adjust their centers according to their geometry. Now we arrange the board models so that they overlap. We give different rotation values to each board model. We can put as many wooden models as we want on top of each other. We select our ground and add rigid body from the physics section. Since our floor will remain fixed on the screen, we set its type to passive in the rigid body section. Since it has a perforated structure, we set the shape section to mesh in the collision section. We open a window from the bottom and open the timeline window from here. Now we select all of our boards and determine one of them as the active object. We adjust the physics settings. We transfer the physical properties to other wooden models by going to the rigid body section from the object menu and clicking copy from active. Now we press play and we can see our wood stacked realistically. We are making our pool model a little smaller. When we reduce the size, press Ctrl A and click scale. Yes, we determine the number of frames we want and stop our animation. After selecting all the wood, we click apply transformation from the rigid body menu. Even if we come to the first frame, the position of our boards will not change and will remain like this. Finally, we select our objects, copy them with Ctrl C, and come to our workspace and press Ctrl V. Now we have added our wooden plank piles to our scene. We can place our wood piles wherever we want. We collect our wooden piles in a collection. Now we import the Ivy generation we just downloaded into Blender. We move the transferred models to an empty edge of our stage. Yes, we cannot put our Ivy on our buildings because our system is having difficulties. If you don't have any problems with the system, you can put it on. I will show you how to add it in detail shortly. I'm organizing our scene a little more. I collect the Haraban models in our scene under a single collection. Now we can add the vines to the objects on the ground. We add one plane. We add geometry node from the add modifier section and select Ivy node. From the target section, we select the collection we created called environment. You can now see vines growing on the models in the environment collection. I'm lowering the intensity a little bit in the eye and destiny sections so that we can avoid contractions a little more. Now all we have to do is copy or extrude the edges on our plane and place them on the models. In this way, vines will start to appear directly on the models with automatic detection. Yes, we placed our vines on our models. Now let's make our settings for test rendering. We switch to the Cycle Rendering Engine. Since I will be rendering with a graphics card, I select my graphics card from the device section. I also set the tiles value to 250 so that it renders 256 pixels each time. We enter rendering mode. We will load HDR in the background for lighting. We come to the word settings section. We select the environment texture from the color section. We choose one of the HDRs I downloaded from Polyheaven. I adjust the camera angle a little more to see the upper part of the city and fill the camera angle with objects on the ground. It seems to be a little better now. To fill the front part of our camera, I copy it from the garbage pile and put it in front. We extrude the plane object to which we added the ivy and bring it onto the pile we placed in front. In this way, the vines are added to our front model. Now we will get our test render. I set the max sample value to 30. We get our render by pressing the render button. 1 minute. Something caught my attention. The buildings appear to be in a single row, so I remove the artificiality by slightly shifting the buildings back and forth on the y-axis. Before rendering, we add a sun lampa to our scene so that we can get a little more sun effect in addition to HDR. I adjust the angle of the sun so that it hits the buildings on the left. I enter render mode with Z. Let's see what effect it has. We open the shader editor to get more realistic light tones. While our sun lamp is selected, we click on the Use Note button above. We can now adjust the sun intensity and color settings of our lamp from here. To better see the effect of our sun, we go to our world settings and set its intensity to 0. The intensity of our sun lamp seems to be good. In order to get more realistic tones, we connect Blackbuddy to the color channel of the emission material. With Blackbuddy, we can achieve realistic lifelike light tones. In this lesson, I will use the value 4500. You can see that we can now create a more realistic lighting when we go to our word and increase the intensity. We set our sample value to 500. We make the background transparent so that we can edit the background as we wish in Photoshop. We activate some channels to use in Photoshop. Now we start our final render by pressing the render button. Yes, our rendering is finished. It looks very nice. Of course, if my system had not been stressed, we would have added factors such as plants and ivy to the buildings. We can say that it was nice this way. First, let's save our render channels. We need to move to the composite panel from the top and get the other channels. By rearranging the windows a little, you can see the press buttons in the lower right corner again. Even though I added Weaver, the rendering does not appear in the background. I select Use Note above and it still does not appear. It starts to appear when you press the backdrop button on the top right. I am testing it so that the channels I will purchase will be cleaner. First, I get the Miz channel. Try them since the other channels are clear, so I don't need to pass them. I detect and save the channels I will receive directly. We open the render we received with Photoshop. We drag and add other channels into our project. We extract it from the Smart Object by right-clicking on the render channels. By turning off the channels, we select only our main render. We switch to the Magitch Ventil tool from the selection tools and select the alpha part where the sky will be. Except for the Miz channel, we selectively delete the black parts of the other channels, which will be the sky. This is how I do the sorting. I set the mixing format of the ambient school beam channel to multiply. I'm making the glossy channel screen. I'm making a glossy channel soft light. By clicking on the top channel, we turn all the combinations we make into a single channel. We do this by pressing the Ctrl, Shift, Alt and E buttons. We select the resulting image and turn on the camera raw filter. From here we make the colors a little more beautiful. I increase the contrast value slightly. I play slightly with the temperature value. I am drawn to light blue tones. I make the tint value like +9. I lighten the shining areas a little more with highlights. I also lighten the shadows a little bit. With white, I open up the whites a little bit. I also open the texture and clarity sections a little bit to get a more beautiful and effective image. I also play lightly with vibrance and saturation. In the curves section, I open up the light and high last section a little. I add some sharpness from the detail section. I brighten the colors I selected from Lumions in the color mixer section a little more. Yes, in general, our camera raw final settings are like this. Subtitle MK. We apply the settings we made to our work by pressing the arrow button. We turn on the HDR we used in the study and select the part that will be the background. After selecting, we copy it with Ctrl-C and come to our own work and press Ctrl-V. I adjust its location by entering free transform mode with Ctrl-T. When the process is completed, I draw the layer at the bottom. I do not use the mist channel because it does not give the effect I want. Now we can print our work. First, we save it as PSD. Afterwards, we can print it as PNG by clicking File Export As. And our work stands before us. Yes, we are finishing this work as well. Thank you very much for watching this far. If you want to support our content, you can like our videos and subscribe. Take care of yourselves. See you in the next videos. Stay healthy and happy.